Okay, so you're in 209, real-time reporting and analytics for construction data powered by Delta Lake and DBSQL. Harry and Jay are going to be your presenters, and they got a fabulous session for you.
Cool. All right. Thank you so much. Can you guys hear me? Good? All right, very nice. So before I start, I just wanted to make sure we obey the legal department. So legal disclaimer, whatever that we are presenting is based on our personal opinion, not affiliated to the organization. All right, so the agenda is as follows. We'll give a brief intro of who Procore is or what Procore is. We will walk through the current system, what we have now, and also the next gen, what we are building with Databricks, what we plan to build with Databricks, and the associated benefits which we have already seen with Databricks and the benefits which we are going to foresee, and of course the next steps moving forward. So raise of hands, how many of you know Procore as an organization? Oh, that's pretty good. So just to level set, Procore is a construction SaaS company. Think about it as Databricks is for data. Procore is equivalent. Its equivalent is for construction industry is Procore. So we are a SaaS company, and our vision is to basically to improve the lives of everyone in construction. We are dedicated to construction and construction alone, and the Procore products are intuitively designed to help the construction builders maximize the return of investment. I'll make sure that it is not a Procore marketing, but I just want to level set things here. Our mission is to connect everyone in construction on a global platform. That's our mission, right? And we incorporate the entire construction project lifecycle in one platform, as you can see, from pre-construction to financial management. That's what the entire portfolio is. And if you look at the bed underneath those four components, you see a construction intelligence. That's what we are going to primarily talk today. And construction intelligence is basically a frictionless solution that provides a streamlined and robust reporting and analytics solution. So again, construction intelligence pillar, we call it as a pillar. And in simple terms, right, this pillar is actually capturing and managing the data within our data ecosystem. And once we get the data in our data ecosystem, we start learning from the data to provide meaningful insights to our customers, be it at the reporting side, be it at the analytics side, be it at the insight side, be it at the AI and ML side, which I'm going to talk about later down the line. So in this talk, I will focus more on enhanced reporting. I'll ensure that I touch all the components, but in this talk, we are going to primarily focus on the first two components, which is enhanced reporting and Procore analytics. So enhanced reporting, it gives our users accurate insights into the construction business and also their field operations in real time. That's the reporting module we are talking about. And Procore analytics allows customers to basically deepen their understanding of their projects. So it's more about, think about it as reporting as more about operational reporting, and analytics as more about wide breadth, like give me a trend analysis, what happened last 1 year, right? So that's more on the analytics side. And Procore Insights, it's more on predictive insights. So we can even forecast the risk of a construction project down the line. So that's with respect to Procore Insights. So let's walk through the current system. Typically, right, most of the organization would have done this. Reporting is generated against an operational data store. That's what the reality is. Because they want a very less latency, both in read and write. So typically, they build a reporting system on top of an operational data store. And then you have your data warehouse, which is for analytical needs. We are no different, at least when we are building the existing system. We had a similar thing. The way we were ingesting data, so we use streaming a lot, Kafka to be precise. And the way we were actually ingesting the data to our operational system is via chain data capture, CDC, so-called CDC. So we get the CDC events from the source, from our database or data stores. We take the CDC, we ingest that to our operational data store, we have our own transaction logic, we show it to the reporting system. That's how the existing system was looking at. We were doing that in our self-managed Spark. So we had our own Spark clusters running on Kubernetes, and we were doing that. Last but not least, we had the so-called canned reports, meaning static reports, which we had in our system. Pre-built canned reports, the user, they don't have a liberty to come and change anything. They just, click on the report and they get the report. One another thing is, as you saw here, we have an operational data store and a data warehouse, right? So that means you can literally make a guess that we had different models. So we had one model for reporting, we had one model for analytical, because obviously data store cannot be a data warehouse, right? So that's an existing system. And while we are doing this, right, we wanted, we had a lot of requirements which were coming in, and we were looking for areas to improve. So one example is, as I said, right, Procore is a construction company, and we literally get petabytes of data. I'm not kidding. For example, we get 10 million documents per week. Think about it per year, how many documents we get, and think about the structured data, what we are going to get, right? And we saw, even in operational data store, whatever we are using, the queries were timing out. Construction domain is a very complicated industry. We had a lot of subdomains, and if you start joining the various subdomains within the construction industry, the queries were timing out. We did a lot of optimization even in our operational data store, but it was literally timing out. If it is timing out now, we can guarantee that it will time out in the next 1 year or so. The other one is, as I said earlier, we want the same model. We don't want to deduplicate the records for an analytical need, nor for a reporting need. We don't want a duplication of record because we want to ensure that a single source of truth happens for both operational as well as for the analytical needs. Then there was this new requirement which came in, right? We had think about it as a white columnar, right? So right, RDS or RDBMS, it's a row level, right? People are saying that, okay, I want to have a dynamic filter for 20 columns, right? We were actually literally going and adding indexes for those columns, and yes, it was working, but after a certain point of time, it did not scale because we started adding more indexes, right? So we were looking for a dynamic filter mechanism, also known as column level data store or data file system or data format, which can serve us that need. I'll just briefly touch only one more thing, which is more about adoption of data mesh principle. Adamant, at least I am adamant on the data mesh. So data mesh is four components, right? Self-service, domain ownership, data as a product, federated governance, right? So these are the four components of data mesh, and we are a data platform team. That's a reality. We both work for a data platform team, and we want to ensure that any domain engineer would be able to do a self-service domain model very seamlessly, keeping in mind that they are the owners of what they are building, right? And we are looking for a platform which can actually help us in actually adopting the data mesh principles. In fact, today morning also in keynote, you would have heard, I believe Ali was the one who said about data mesh principle, or Larry, I believe. So it's one thing which we wanted to embrace right from day one, at least when we started looking for areas of improvement. And so we are looking, we did a lot of, very honest, we did not pick Databricks just like that, right? We did a lot of comparison when we picked Databricks. Databricks folks are right there. They did an awesome job in actually helping us doing that POC. And then we were looking for an open data model. In fact, today, I believe Ali was the one who said, right, we did look literally, we did the comparison of Delta Lake, Iceberg, Hoodie. We did that. We literally did that because we wanted to look at that open data format. And we went for Delta Lake. And I was so happy when Ali made that announcement that we are going to have a unified metadata management. which is going to be useful for us because down the line, even if we flip to Iceberg, we are not confined to anything specific to Delta Lake or Delta format, I'm sorry. The other one is data catalog interoperability. As you're aware, right, so data platform, there are two components which you need in data platform, not two components, at least major components, data catalog, data governance, right? And we did not, we had a catalog, but it was not that robust enough to scale. So we are looking for something which can actually, scale from day one, and Unity catalog was one of the things which I will definitely talk about it. But that is also one of the components which we are looking for. Data governance, which I said about the row level permissions, right? So the next gen, what we built. So the way we are going to now speak about this, right? The architectures, what we did to build this data platform. Again, to be honest, this is just, we have just started to scratch the surface. I mean, there are a lot of things which we need to mature on. So the next 3 slides, which you are going to see, we are going to talk about the infrastructure architecture, the data architecture, the system architecture, and I hope you will get some hints on how we did it. So as you can see from the slide, let me see if I can point my arrow. Do you see that? No, okay. It doesn't work, that's fine. All right, so you can see, right, on the left-hand side, you see the control plane, the Databricks control plane, right? So as you're aware, the architecture, we have control plane and data plane, right, in Databricks. But you also see a middle layer, which is the data plane, and you also see the last layer, which is basically the data account, that one. That's a data account. And we have the relationship between this control plane and the data account, but we also have something in between. And the reason why we have that in between is because of 2 things. One is one for security reasons. The other one is Databricks is an awesome company. I mean, there's no question in my mind, it's an awesome company, right? But our security team came in and said that, hey, you know what? It's not only Databricks we are going to have it as a SaaS, we are going to actually have different SaaS companies down the line. So we want to avoid the zero-day attack in case if something happens with any SaaS vendors which we are going to go for. So, right, so that's the reason we have this pattern of introducing a new layer in between where it actually has a relation between the control plane and the naked VPC. All it does is it just has a EC2 running. That's what it has. It has EC2 running. And the relationship between that data plane and the data account is done either via, for example, AWS, you can actually use VPC peering, transit gateway. You can actually use that so that you can actually have the data access from the middle account layer to that data account. And in case if something happens, all we do is we just cut off this. We just cut off this network so that zero-day attack doesn't happen at any given point of time. So that's a fundamental difference between how Databricks actually shown in their documentation. They would have shown directly from that thing left to right. We just introduced this layer because of Procore needs. Let me put it this way. I mean, because of Procore needs, we just want to make sure that we are safe and sound, considering we have a lot of confidential information about construction industry. We just wanted to have this layer.
Right, let's talk. Can you hear me? Oh, sorry. Let's talk about data architecture. So can we get a show of hands how many people are here familiar with medallion architecture? Cool. You must be familiar with this as well. Let's dive into that. I will share with you how Procore is implementing this. In Procore, before we do that, let's have a level set just to make sure everyone understands what is medallion architecture. So medallion architecture is the data design pattern that used to logically organize the data in lakehouse. Now it become the standard of implementing the lakehouse. And it has 3 layers. And the bronze layer, it'll be raw and ingestion with all the history data. And silver will be cleansed, transformed, and augmented data. And gold will be our business aggregates. So in Procore, we have multiple types of source, like any other companies. And we have Kafka that are produced from different sources, including domain events and also CDC events from different relational databases. And we have files and logs generated by internal services. And we also have the data generated from ML team using Spark. So all those data will flow into the bronze layer, a landing zone, categorized under bronze. And they will be used for replay, troubleshooting, and validation purposes. And the silver layer will be transformed and compacted using our ingestion transformation pipelines. And they'll be categorized by the domain and source. And Go layer will be the one, the domain team will come to create data models and generate basically the data models from it. And on the right-hand side, we have our consumers, and we have a diverse set of consumers. As Harry mentioned in the previous slide, we'll have more customer on board to this picture, and very soon. Let's dive into how we are implementing this at Procore. Right, let's talk about a few different key use cases. Let's start with change data capture from relational databases. So the CDC events generated from, we're using Debezium to produce the message, and the data will be landed into bronze layer using a sink. We'll create a table on top of them, so it'll be used to access that for troubleshooting validation purposes. Once we have a second line from Spark structure streaming that read from the topic and ingest into the silver layer. And here, we have our source transactional logic awareness here. We are able to achieve transactional awareness within the lakehouse. So why we need that? So in a lot of analytical use cases, probably we don't really care about transactional at that level. But we have financial reports that in construction, we need to have consistency and atomicity, meaning when a transaction is applied on multiple tables in the same transaction, we either get all of them or none of them. As you know, Databricks provide transactions at table level, meaning it doesn't have the cross-table transaction yet. What we have to do is we have to implement our logic to build on top of it to provide the transactional awareness.
Can you explain more?
Sure. So when we get the stream from CDC, we also get the metadata, transaction metadata. So what it tells us is what tables changed in which transaction. And with that information, with the CDC stream, we're able to figure out what transaction is fully available in the stream and what transaction is only partially available, which we cannot merge them into the table yet. We're processing this in a structure streaming, so we have them in every single batch, micro batch. So we only gonna write those fully available transactions in their target table. So at end of, including the batch ID, every single batch. So at end of each micro batch, we record that batch ID into a process table. So when we're reading from those tables, we're always looking at the batch ID that is before that last processed. So that way, we can achieve cross-table consistency on read. And we hope Databricks will provide that function one day so we don't have to have those logic. Let's talk about domain events. So the domain events are produced from microservices or directly from DBSQL outbox pattern. So they'll be, like CDC, they'll be landed into server zone first, sorry, a bronze first, and we have ingestion pipeline. They'll be ingested them into server layer. So because these domain events are self-contained, so they don't have to worry about the same thing that we were talking about CDC, because they'll be in a message self-contained, so it'll be either processed or not processed. Now the data is in server, we can start to do the modeling for the gold layer. At Procore, our domain team is using dbt to create the models using DBSQL. And we can later materialize the tables, depends on the business need and the performance need. Once the data is in a gold layer, create a model and materialized, now we can serve them. So traditional way of serving the data is, you have your non-running cluster, and you have to pre-plan your capacity to support the peak load, which means if you don't have that volume, your cluster is still running, so you waste the money. And Databricks has this serverless SQL warehouse. You only need to decide the size of the cluster and the number of min and max number of clusters. It will scale up from a fleet of instances within seconds, and it will scale down when the volume is very low. And you can have a setting to terminate that cluster using an idle timeout.
Sure. So I just want to level set on the domain side, right? The so-called gold tables. So we use dbt as our semantic layers to create our gold model from the silver table. So that's the reason that component is critical, because it establishes relationship between the domain, the so-called dbt layer with the SQL warehouse, so that we would be able to run everything in Databricks against the serverless workload. We also touched upon Procore Analytics, right? So what we have done is we have connected our JDBC connection from Power BI. So we have, by the way, to level set, Procore Analytics dashboards are either via Power BI, Tableau. That's what the Procore Analytics is all about. It is actually exposed to the external users. The way we have done with Databricks is with the serverless JDBC component, JDBC protocol, we are able to connect it, and it will run only on need basis, and it was able to scale. We were able to test it seamlessly right from Power BI. We were able to do load testing also. It was able to scale accordingly right from Power BI to Databricks SQL warehouse. One more thing which we also want to talk about is Delta Share. I'm sure you would have heard about Delta Share in the keynote and also in other sessions too. In my opinion, and in Jay's opinion too, Delta Share is one of the best thing which I would have seen Databricks has provided, apart from Spark and MLflow. It is Delta sharing is the first open secure protocol wherein you can use Delta Share to share your data within your organization across zones, or you can actually use Delta Share to share your data across organization. In the keynote, she showed, right, the marketplace concept with Delta Share. That is something, which is really fascinating, right? Because Delta Share is now enabling that. You don't need Spark, let's put it this way. You don't need Spark to use Delta Share. If you're using Python, just do a pip install of Delta Share library, boom, you get it. If you're using Rust, you have a Rust library for Delta Share. So Delta Share, there are connectors even within the BI to Delta Share, so that you should be able to share your data in a non-Databricks environment too. So we use Delta Share, at least now, coming back to Delta Share with Procore, what we have done is, Procore is a SaaS company. We have more than, I would say 10,000 customers, right? We have, the customers are across zones, right? So what we have used Delta Share is for, ensuring that the customers, the data across zones can be accessed as if it is coming from a global global zone, right? So for a customer, it is invisible. So let's say assume that one general contractor in the construction industry, they are working in both the zones. For them, they will connect to only one zone, and they would get both the data. They don't even care about which zone it is actually going to lie, right? And we use Delta Share to basically share the data between the zones. And that's the reason you would see a Delta Share over there, because that will play a critical role in Procore analytics, because it is a global system.
Cool. Another thing is the data quality. I think the data quality is a crucial part of the data platform. So we have a collection of validation jobs here to validate each layer of the data. And in conclusion, I think with this architecture, we're able to alleviate the need to maintain different data store, different models for OLTP and OAP needs. So we're able to use a single model to power both of them.
Perfect. Yeah. So these are the advantages which we have seen, we are just coining this new term called OLTAP, because as I said, right, we don't want a transactional-based system, an analytical-based system doing the same thing. We want everything to be done at one single data store, which can actually satisfy the need of transactional-based system plus the analytical system, be it operational, be it trend analysis, be it ML and whatnot. So, just coining this new term called OLTAP, which I'll do a trademark soon. But that's the thing which we see an advantage, because we have now single source of truth for the data that is coming at the source level, rather than bifurcating into different data stores. Then we also saw the quick benefit on time travel, SCD2. So I don't know how many of you attended training last 2 days. In the advanced data engineering session, there was this talk, right? They were talking about how append is very fast and how append is critical, and you should be able to do a SCD to time travel analysis. And we are no different. We also use the same logic of append. Basically, there's no merge, right? So what we do is we do append. So the latency of write is probably milliseconds or seconds, right? So we get the records, and then we do our transaction logic, which Jay pointed out. And with the help of this time travel, ML engineers are able to now actually do their raw data analysis and create their predictive models. The other thing which I wanted to really point out is near real-time ingestion. I want to be very careful on why I did not write real-time, as we are still getting there. When I say near real-time, I'm talking about seconds. When I say real-time, I'm talking about milliseconds, right? So right now we are in seconds. We are still not in milliseconds. We are able to achieve near real-time. Before this Databricks thing, the reports, the models are created on a daily basis for Procore Analytics, because it was a more global zone. It was taking time. Now we are able to achieve the Procore Analytics data, even it's up to our will. Right now we have configured to 5-minute interval, but we can even make it a minute interval too to ingest the data. For reporting, we are able to see the reports. Even for complex queries, we are able to see the reports in seconds. The complex queries, beware, the complex queries were literally timing out in the operational data store. There were queries which were taking 40 minutes in operational data store. In Databricks, it took 40 seconds. So that's the reason I'm being very specific that yes, it took us 40 seconds to build that report, but when compared to 40 minutes, I'll take it on any given day. So we are still working on to improve that readability from the reporting perspective, but that is something which we are working towards. Last but not least is data mesh principle, which I quickly talked about, right? Federated governance. I want to be very specific about Unity Catalog, which you knew about that in Keynote. We have been using Unity Catalog. I did work with the Databricks folks a lot on Unity Catalog product features. It's one fascinating, I would say, a data governance solution, which can actually not only help us in data lineage, right? For example, right, we said, hey, we need a role level security because we don't want to expose all the customer data to, I mean, of course, we can actually create a dynamic view and do all those things, but we want a role level security, right? And Databricks was, when they were very easy to work with, and they actually released a private preview for us to test the role level security feature with Unity Catalog. Not only that, Unity Catalog, again right, it is across zones. We should be able to use Unity Catalog to point to your West data easily with a click of a button. And then lineage is out of the box with Unity Catalog, apart from the other features of permissions in Unity Catalog. All right, what are the key metrics? What did we gain? And this is just, we are scratching the surface. That's the reality. I mean, we firmly believe that it is going to take another 2 quarters or 3 quarters to basically refine these numbers. But what we immediately saw with the adoption of Databricks for reporting and analytics is, these are numbers, right? Complex queries, 100, I would say even 100%, because it was timing out. And with Databricks, we were getting the results. And the other one which I am really interested is the data availability, which is 90%, right? Procore Analytics, now users can get their data within 5-minute interval rather than waiting for a day. This was definitely done via Databricks. One more thing is ML flow. I promised that I'll touch upon the ML needs, which is actually in the next slide. Okay. So we are using open source ML flow, and we would be actually looking forward to adopt the Databricks ML flow. In fact, we already started, that's reality. And we are also looking at the components of the LLM, right? The Lakehouse AI, which we are literally looking to work with Databricks on. We have already started the conversation to build the LLM models, right? Because as I said, right, we ingest 10 million documents per week easily, right? So if you want to do that, do the LLM models, do our context-based models, we would be looking to work closely with Databricks. And the other thing which I said at the last is the Delta Live table, which you would have seen also in the keynote. We have already started looking at Delta Live tables because DBT models, right? DBT models and Delta Live tables. We are thinking about incorporating these two things in tandem so that we can actually make that seconds, whatever I said, that seconds to milliseconds. So we will actually explore the Delta Live tables, aka DLTs, for our ingestion so that we can actually expose the data to the users. One more thing is data warehouse migration. I mean, it's a no-brainer. So we use data warehouse. And we definitely want to migrate whatever we have in our data warehouse to Databricks in the future.